All right, so today I have my service monitor here, and I'm going to be testing this Quansheng UV-K5. We're going to put this on the service monitor and check a couple different things. We're going to check receiver sensitivity, transmit power out, deviation, and with the spectrum analyzer here, and a 500 megahertz in the middle, so it'll be 1,000 megahertz here to see any kind of spurious emissions. All right. I went to rigpix.com. That's kind of a, a lot of people have that site, and I'm looking at the specs here for the deviation, the power, 5 watts on high, 3 watts on mid, 1.5 on low, as well as the 12 dB Sinad for the sensitivity on the receiver, both in AM and the AM airband, as well as FM, UHF, and wide FM, which would be your FM broadcast. And then what we'll do after is I'm going to flash the firmware onto this, the Examer flash firmware, and then I'm going to go through and check this on different bands, power output on, say, 20 meters and 800 megahertz and some different bands, and see what it does. So first thing I'm going to do, this has been sitting here for about 2 hours. It's warm. I always want to make sure you warm up your service monitor. I have a TIMS up here also, just for, not needed because I can get the Sinad on here, just for verifying. I could see my 1,000 hertz tone here, as well as my 12 dB up here, which this one on the screen here that's going to show you, and here it's not a very fast number on here, so I can kind of get an average and look, okay, I'm in within 12, the 12 dB spec there. Very, not a service monitor where you can get an actual 100th or 1,000th of a millisecond measurement. So let's do this. First thing I'm going to do is I'm going to go to, I have my okay, hold on. I have the I have the signal coming in on the receiver here, and I have output of the speaker jack to the Sinad in. I also have some leads down here clipped for my TIMS up here. So I'm going to start at 146 megahertz, and the RigPix website here shows that in the center of that band, let's see, 136 to 470 should be 0.16 microvolts. That's the spec that they have. So could it be better? Probably. Let's check it out. We're going to go to generator here, generating at 146 megahertz here. Okay. Now you'll see I have the Sinad here, as well as the Sinad up here. I'm going to turn this AF here, right here. All right. Now, as you can hear, I'm sending a tone right there, but I'm running that back into the service monitor. Right now, with 60% modulation, with no CTCSS or DCS, 60% modulation at 1,000 hertz tone out of the transmit receive port, I'm getting about at 0.09 microvolts, roughly to 12 dB. And if you can look at both of these here, if I go up, if I go to 0.1, here's 13 here, here's 14 here, 13 here, 14 here, so it's about average, right? So we're going to go down, and I'm going to call it 0.09 microvolts, which is actually really, really sensitive for that kind of, for their manufacturer's spec, okay? Now I'm going to go down to let's do 136. I'll go to the bottom end of what they rated that as. I'll set the radio to 136, 0, 0, 0. Okay, and right here at 0.9 microvolts again, I'm looking at this. I could even go down to 0.8. I'm not sure. I'm going to say 0.9. I mean, 0.8 is really, really, really sensitive. It's way beyond what they said it would do, which could, it could be a very hot receiver, which would allow more, spurious emissions and stuff into the receiver. But for a 12 dB Sinad, you can see here, it's going up and down, but around 12 dB, around 0.9. Let's go up to the top of the band here. Let's go to 470, because they said 0.15 from 136 to 470. So we'll do that. We'll go 470. Okay. All right, 470. Make sure my leads aren't touching down here, because they are. That's for the audio out. I have it paralleled, so I have audio going up into here and audio going into here as well. All right, so 470 now, again, at 0.9 microvolts, which would turn out to be neg 127.9 dBm, which on some other sites said less than that, like 125.6. So it's actually, you know, depending on what site you go to. I'm looking at, let's see, let's go up here, back to microvolts. All right, we've got 0.1 microvolts. All right, that's still a little high here and here. It's up and it's almost there. You want to call it 0.19, 0.09, 0.10. Okay, and the reason that my 1,000 hertz tone is not stable up here is because the receiver's hardly saturated. If I go like this, see, I can get my 1,000 hertz tone there, stable. If I go up, right, look. I mean, that's very low. That's usually a good FM receiver. You'll be up at about 0.19. You know, my ID52 specs will say 0.20, you know, but look, at 0.19, we're at 25, so we got to come way down. All right, so, wow, very, very sensitive, okay, very sensitive. Let's see, what can I do here? We can go to, let's go to the AM, all right? Let's go up here to the AM. We'll go 120 right in the middle, because I don't want to keep this video short, you know. I'll set this to AM mode, 120. Okay. All right, 120, we're going to bring this down to AM. At 60% modulation. All right, now they're looking for a 10 dB at point. Okay, this one's not even detected because it's so low. Look at this. There you go, okay? Wow. 0.17. Look at it, 10, 11, let's go down one. 0.16, we got 10 up here, we got about, you know, you want to go good, let's call it 0.16 microvolts, okay, which could be neg 22.9 dBm here, okay, I like the microvolts, I'm used to that, right? So that's 0.5 is what Quansheng says, so that's way better than 0.5 on your AM, you know, airband. Wow, not bad. Okay, so far much better than a Baofeng, and much better than COM ID52. You wanted to see the proof, here it is, and I'm telling you all, eat crow. That's why the comments are off. Now, okay, the last thing we could do, let me see what my memory card's doing here. We got 1 minute on memory card. All right, let's do this. Let's go to receive, and we're going to transmit at 146. No, 140. Let's do 140. No, let's do 146 because that would be in the designed band. Of course, you know, there's nothing outside of. All right, there's 146. Okay, now if I transmit, I have 3.83 watts, supposed to be 5, not bad. Now my deviation here, okay, on narrow or wide, if I take this, I pull this out, and I take this and I run a test tone into it before my memory card goes bad, I'll take this phone and I'm going to fire up this app, go like this. All right, it is transmitting. You see it transmitting, all right? Now, deviation 2.29, not to exceed the 2.5. Yes, it does not. We'll go to wide mode. So narrow, let's go to wide. Whoops. Menu. I know you can't see. I got tight cables here. All right, wide, not to exceed 5 kilohertz deviation. And I'm just blasting this with audio at 3,400 hertz. All right, and there you go. Whoop, what happened here? Hold on. There you go. Okay, so here is out of 5 kilohertz deviation, okay? You can't hear that because I don't have that plugged in now up here. 4.48, so it's not over deviating. It's within spec compared to what the manufacturer had said. So 3.75 watts at the middle of the 2 meter band, less than 5 kilohertz deviation. Okay, so what we'll do now is we will take this here, which I'll show you again. All right, now I don't have any audio coming out of here now, I don't need it. We're going to go to the analyzer. Now this would be essentially 1,000 megahertz, 500 in the center. Each line would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1,000. And we're going to see when I transmit at various places what, you'll see the carrier frequency, the carrier, and then you'll see any harmonic spurs. And I think the FCC says, what is it, 40 dB down from the original carrier level for maximal permissible, maximum for spurious emissions. So what we'll do is I'm going to go down to, of course, out of the ham band. And again, I'm not IDing. I can transmit wherever I want because it's going right into a dummy load essentially. This service monitor will handle 200 watts right here into this port here on the front. So I could transmit up to 200 watts when I'm tuning repeaters or when I'm measuring repeaters for a 12 dB Sinad or to voting companders and stuff like that. What I do is use this to transmit right into and transmit out from the antenna port or out from the aux port or in Sinad. I can do a lot of different things with this. All right. So 136. So you're going to see the carrier and you're going to see any other sporadic or spurious emissions on here. And we'll transmit like this. Okay. You can see this is the radio here. See, look. Transmit. Okay. Now, there's your 136. And you have something around almost 300. So in the 260-ish here. And then somewhere here at 400. Some here at the 550. Okay, that would be, of course, you shouldn't be transmitting at 136 for really any reason, all right? We're going to go to 146.520. I'll transmit again. That's national simplex calling frequency, all right? Now, it takes a little bit to sweep here. So that'd be almost 150 right in the middle, okay? Something right at almost 300, and now it popped up with something over here by the 900 in the 870 megahertz rare, something here, so it's some sporadics. If I were to turn the attenuator on and bring this down, I could see, well, we won't do that right now. They may be within, I'm not calculating this in my head right now, I'm just trying to make a video, but they may be within mass, depending on what the original carrier is here, depending on what this. So that would have to be plus 30 or more, I think, in order to be maximum permissible, or third, fourth, fifth, sixth harmonic, whatever. Okay, so let's go to 350 because that's somewhere we should never be transmitting at as hams, right? But the radio will do it, and when I get the firmware flashed on here, we'll check this out at 20 meters and 10 meters and wherever else. CB. 800 megahertz, 12.96 gigahertz, whatever, 1296 megahertz. We'll try that. Not that you would ever, maybe you could, who knows? Y'all wanted proof, here it is. And of course, it's looking pretty good on the receive sensitivity right now, but we'll keep going. So here's 350 megahertz. It should be somewhere right about here. There it is. Okay, and there's a big one right there at 700 megahertz. Okay, now that I could tell you right now, if I turn this attenuator on, right, like this, that's transmitting. Okay, so there's yours there. Now it say 700 megahertz. So that's half. So if that's 33 dB, this is 18. So that's a spurious emission right here. But of course, you're not going to, right at 700 megahertz, but you're not going to be transmitting anywhere at 350. So I don't, is that a relation to where your carrier is, why that's popping out? We're not sure. Let's go in the ham band again. Let's go 446,000, and that would be the national simplex calling frequency. We'll take the attenuator off. Okay, so that should be right up over here, right below the 500. Okay, and there's that little spike there at like 890. All right. So not too bad on UHF. Let's go into GMRS. Let's go to 462.5625. Well, 462.55. Okay. We'll transmit there. That should be right here. All right. And really clean on, as far as I could see, up to 1,000 megahertz, really clean at 462.55. So pretty good for GMRS. Let's go up into can we transmit at 470? Not that you would do anything for that, but let's see. 470.000. Okay. There's 470 transmitting. All right. And so that seems to be moving up here, and that's in like the 920, 930. Now, could you be, if you were for some reason transmitting at 470, could you be interfering with somebody else at 930? Of course you could. If there was something using 930 megahertz, you could potentially be causing disruption to other frequency allocations for other sources of using radio, okay? That's the idea here. Now, just because I have this set up here, I'm going to take this off, and we're going to do the same, almost the same thing right here on the Baofeng, just to see, because people said that the Baofeng was cleaner, and it may be. So we're going to find out. This is a UV-5R. I did not pull up the specs on this. We're not going to do receive sensitivity on this yet, but we have time to do that in the future, hopefully. All right, so let's go back down to 136, and we're going to transmit. All right, now you should see that. There's 136. Ooh, a lot of spikes. Look at that. All right. So you have different orders of harmonics. You know, every so many kilohertz or megahertz, you have harmonics. So, for instance, that would be 400 megahertz right there. You know, you could be causing interference or making noise if you had something in that range. All right, let's go to 146.520. And we'll hit transmit here. All right. That's your simplex calling frequency. That is pretty bad. The Quansheng wasn't that bad. Didn't have that many spurious emissions on 146.52. Okay, let's go up to 3. This won't transmit 350, will it? I don't think it will. Never had to transmit there. No, only receive it. Okay, so that one, Quansheng, will receive it. This one will not. Let's go to 446.000. That would be your national simplex calling frequency for UHF. We'll transmit here, okay? And I'm sure you're going to see a little, there's that little spike at 880 megahertz. So that is, I'm not sure if there's anything there, but that's about what the Quansheng had. And then we'll go up here to 470.000. We'll transmit there. Let's see. All right, 470. Not so bad there at 470. But hey, you know, either one of these. Now, I can tell you if I had the right, well, if I had the camera battery left, I'll show you that in the next video. We'll do an ICOM and a Yaesu to show you just how clean that is. How there's really no specs on there, or spurious emissions. Overall, though, not to be on the Baofeng here, the Quansheng looks like it's actually really sensitive on the receiver sensitivity, meeting the manufacturer's spec, which was produced in the technical data on the radio. Specifically, I got it on rigpix.com. Not out of deviation, not out of band, not over deviating. Okay, some spurious emissions. I guess I could go further into that and exactly with attenuation and see exactly how many dB below the carrier frequency that is, or the main carrier, to see if it was in spec, because every radio might have some sort of spurious emission. But as far as the power out, we were seeing what, 3.7 out of 5. I didn't do low, but not 5 watts really. And the, you know what, the RF error. Do I have enough battery voltage? Let's find out. In my camera, rather. You guys think I have some sort of studio? I mean, I do this on my phone half the time. All right, let's go to 146.520. And looking at the RF error, wow. I mean, you wouldn't be able to detect negative 0.005 kilohertz off frequency. KJ4YZI testing 1, 2, 3, 4, 5. So that's on wide, just under 4 kilohertz deviation, and the frequency, of course, there's your power output, 3.8 watts on simplex here for 146.52, and your RF error is really not that bad. So let's just do 446.000. 3.37 watts. So it's neg 0.028 kilohertz off frequency. Not terrible. KJ4YZI testing 1, 2, 3, 4, 5. So it's not over deviating on wide. If I go to narrow, we're on narrow right here, if you can see that. 1, 2, 3, 4, 5. So that's as steady as I can make my voice, less than the 2.5. So there you go, guys. We can get into testing the sensitivity of the tone squelch decoding for DCS or CTCSS. If I wanted to go down here and turn this on to generate, you wanted to go down here like this and turn this to FM, right? And you can go like this. You turn that to data. I can turn on DCS. That would be your DCS, inverted or regular with the code. And I could decode that and see the sensitivity with your 1000 hertz tone and your subaudible carrier or digital coded squelch on top of it. We won't need to do that though. Other than that, next video comes soon.